sklearnimputeKNNImputer. Description: the KNNImputer class in scikit-learn sklearn is a powerful tool for handling missing values in your dataset using a k-nearest neighbors KNN approach. This method finds the k-nearest neighbors to a data point with missing values and uses the values of those neighbors to impute the missing values. Inputs: X. This is your input dataset, represented as a NumPy array or a pandas data frame. It should contain missing values indicated by none, not a number. N neighbors. This integer parameter specifies how many nearest neighbors to consider when imputing. A higher value means more neighbors are included in the imputation process. Outputs: Zimputed. The output is your original dataset with missing values filled in using the KNN imputation method. Steps: finding nearest neighbors for each data point with missing values. The KNNImputer identifies the k-nearest neighbors based on the similarity of features. Calculating weighted average. The missing value is then imputed by calculating a weighted average of the corresponding features from the k-nearest neighbors. The weights can be based on the distance between the missing data point and its neighbors. Metrics: mean, absolute error, may the average difference between the imputed values and the true values. Root mean squared error. RMSE measures the average squared difference between the imputed values and the true values. Visualization plots: scatter plots. You can visualize the imputed data alongside the original data to see how the imputed values fit within the overall distribution. Histograms analyze the distribution of the imputed features to understand the impact of the imputation. Fine-tune parameters: N neighbors. Experiment with different values to see how many neighbors lead to the best imputation. Results: a larger value might smooth out the imputation but could also lead to overfitting. Weights: you can choose how to weight the contributions of the neighbors, uniform or distance-based. Uniform gives equal weight to all neighbors, while distance gives more weight to closer neighbors. Metrics specify the distance metric used to find the nearest neighbors, e.g. Euclidean, Manhattan, etc. Uncertainty methods: confidence intervals. You could calculate confidence intervals around the imputed values to indicate the level of uncertainty associated with the imputation. Ensemble methods use multiple KNNImputers with different parameters and combine their predictions to estimate the uncertainty. Challenges and fixes. Challenge 1: high-dimensional data. The KNNImputer might struggle with datasets containing many features. Finding true neighbors becomes challenging in high-dimensional spaces, leading to less accurate imputations. Sample use case: a dataset with 100 features, where many features are irrelevant or have high correlation, causing the KNN algorithm to be less effective. Fixes to challenge 1. Feature selection: use feature selection techniques to reduce the dimensionality of the dataset. Before imputation. Dimensionality reduction: apply techniques like principal component analysis (PCA) to project the data into a lower dimensional space. Challenge 2: imbalanced data. If the dataset has an imbalance in the distribution of classes, the KNNImputer might favor imputing values based on the majority class, potentially leading to biased results. Sample use case: a dataset with a rare disease, where most data points are from healthy individuals. This imbalance could lead to the KNNImputer imputing values for diseased individuals based on the majority healthy individuals. Fixes to challenge 2. Oversampling: use techniques like smooth synthetic minority oversampling technique to create synthetic data points for the minority class. Balancing the distribution. Undersampling: remove data points from the majority class to reduce its dominance. Weighted KNN adjust the weights of neighbors to give more influence to data points from the minority class.